Introduction. Gas chromatography (GC) is an analytical technique used to separate and analyze volatile compounds in a mixture. In this method, an inert gas such as helium or nitrogen is used as a mobile phase to carry the sample through a column that contains a stationary phase. Different components in the mixture move through the column at the different speeds due to differences in their interaction with the stationary phase, allowing the components to be separated. As the separated components exit the column, they are detected using detectors such as flame ionization detector (FID), electron capture detector (ECT), or thermal conductivity detector (TCD). The detector signals are recorded as peaks on a chromatogram, where retention time is used for identification and peak area is used for quantification. In this experiment, we have 4 objectives, which is the first one, to determine the retention time (TR) on N-butanol and 2-propanol. The second one is to identify the components present in a standard mixture based on TI, which is retention time. And the third one, to identify the components present in an unknown sample. And the last one is to determine the effect of temperature on TR and RS. Here is the list of apparatus and chemicals that we use in gas chromatogram GC experiment. The first apparatus is beaker, shrink, filter shrink, dropper, and vial. And the chemical that we use is 2-propanol, N-butanol, standard mixture of 2-propanol and N-butanol, 1:1 ratio, and the last one is unknown sample.
In this slide, we will talk about the procedure that has been done when we do the experiment. The first step is sample handling. The syringe was rinsed with the sample and filled beyond the target area. Then bubbles were removed, and by gently tapping the syringe barrel, the syringe was held vertically and the plunger was adjusted to the required volume at eye level. An excess sample of the needle tip was wiped away with tissue. And the last step is preparation and injection were executed quickly to prevent the loss of volatile components. And now B. Experimental. The gas chromatograph was switched on and the oven temperature was set to an initial and final temperature 70 degrees, and preparation and injection were executed quickly to prevent the loss of volatile components. The injection and detector temperatures were both maintained at 180 degrees, ensuring the detector temperature remained higher than the oven temperature. Individual samples were injected to determine the specific retention time for each. The standard mixture was injected and components were identified by comparing retention times to the individual standards. An unknown sample was then injected to identify its constituent components. And lastly, to study the effect of temperature of retention time and resolution, the column temperature was adjusted to 100 and 140 degrees for subsequent injections of the standard mixture. And lastly, the operation of the GC. The Jamilin 6890 instrument was initialized by ensuring that the column was secured off mode, followed by switching on the power. The software was accessed by clicking Instrument 1 online to allow the system to perform its internal setup. Once ready, the Edit Entire Method option was selected to input the run title and verify that all the systems were correct before proceeding. The injection parameters were set to manual through the back end with the mode toggle between split and splitless based on the sample concentration. Column number 2 was designed for use under constant pressure with an ambient outlet, and the front flame ionization detector was selected. After setting the injection volume to 1 ml and the run time to 5 minutes, the settings were applied and the method was saved to the system. Last but not least, the operator name and sample information were entered into the run control section before clicking run method to prepare the instrument for injection. Using both hands for a quick and steady technique, the sample injected into the sector and start button was pressed, and the syringe was repeatedly withdrawn. Following the run, the signal was loaded in the data analysis menu and a new calibration table was generated to print the final output. What you're seeing here is the virus rate. This typically holds to a number of vials that can be processed then one by one according to a sequence we set in the software. And the reddish orange circle in the center of the blue cap is the sector, a rubbery material that a needle can pierce to suck out the liquid and then self-seal once the needle is removed to prevent evaporation. And the yellow labels on the vials is used to identify the samples, which is either blanks or standard or specific samples. This whole process will start by the robotic arm moves to the specific number slot, then it will lift the vial out of the tray, and then it will carry the vial into the ejector towel. The syringe then pierces the blue cap, draws a tiny amount of liquid, and injects it into the hot inlet of the GC. And once the injection is done, the arm places the vial back into its original slot in the tray.
So the result for compost standard mixture, temperature 70 Celsius, the retention time we got 2.832 and 3.320. And then for 2-propanol, temperature is 70 Celsius. The retention time we got is 2.812. And then for N-butanol, temperature 70 Celsius. The retention time we got is 3.355. For unknown sample, temperature 70 Celsius. The retention time we got 2.815 and 3.328. And then for standard mixture, temperature is 100 Celsius. The retention time we got 2.532 and 2.721. And then the last one is standard mixture. Temperature is 140 Celsius. The retention time we got 2.386 and 2.332. So the discussion, this experiment was carried out using gas chromatography to determine the retention time of N-butanol and 2-propanol, to identify the component present in the standard mixture, to identify the component in an unknown sample, and to study the effect of temperature or retention time and resolution. Based on the result obtained, N-propanol showed a shorter retention time compared to N-butanol at the same column temperature. This is because 2-propanol has a lower boiling point and weaker interaction with the stationary phase, causing it to elute faster from the column. In contrast, N-butanol has a higher boiling point and stronger interaction with the stationary phase, resulting in a longer retention time. The standard mixture chromatogram showed two distinct peaks with retention times corresponding to 2-propanol and N-butanol. This confirms that the component in the standard mixture can be successfully identified based on their retention times. When the unknown sample was analyzed, its retention time was found to be close to that of N-butanol, indicating that N-butanol is present in the unknown sample. The effect of temperature on retention time was also observed. As the column temperature increased, the retention time of the compound decreased. This happens because higher temperature increased the vapor pressure of the analyte and reduced their interaction with the stationary phase, allowing them to move faster through the column. Consequently, higher temperature shorten analysis time, but may reduce separation if it is too high.
Next is question. For question 1, state the type of compound which are suitable for analysis using GC. The type of compound which are suitable for analysis using GC are hydrocarbons, halogenated compound, compound containing halogens, sulfur or nitrogen, and organic compound. Second question is, why is FID suitable detector for this analysis? FID is a suitable detector for this analysis because the compound that has been used is an organic compound, thus it will ignite in a flame that is made from hydrogen and air. The compound then produces ion as they burn. This ion conduct electricity, where the changes in current within the flame are measured and seen as peak on the chromatogram. And third question is, list two factors which can increase the efficiency of a DC column. First is the length of the column. Second is reducing the packing size of column. So for the conclusion, in this experiment, gas chromatography was successfully used to determine the retention time of third-butanol and 2-propanol, thus allowing the identification of the compound based on their chromatographic behavior. Standard mixture analysis allows for the accurate identification of each component through comparison of retention times, which are then used to identify components present in unknown samples. In addition, the effect of column temperature on retention time was studied, where increasing temperature caused a decrease in retention time due to reduced interaction between the analyte and the stationary phase. Overall, this experiment achieved all objectives by proving the reliability of retention time as a qualitative identification parameter, as well as demonstrating the significant influence of temperature on the efficiency of chromatographic separation.
In this slide, you can see all the references that we used to refer when we did this experiment report.